investigation. Silver nitrate was reacted with copper wire to produce silver metal and copper nitrate. The aim was to test if the copper used was a 1+ ion or a 2+ ion. The concepts that we used in order to successfully complete this investigation were the mole concept, balancing equations, types of reactions. New terms that we learned were spectator ions, oxidation, and reduction.
Oxidation is the process or result of being oxidized, that is, the gaining of oxygen. Copper was found to be the oxidizing agent in the reaction we conducted. Reduction, the process or result of being reduced, that is, the loss of oxygen. Silver was a reducing agent. Spectator ions. A spectator ion is an ion that exists in the same form on both the reactant and product sides of a chemical reaction. In our reaction, nitrate, or NO3 negative, was a spectator ion. Our equation was copper metal plus silver nitrate yields silver metal plus copper nitrate. Copper was found to be the oxidizing agent, and silver was the reducing agent. Nitrate was a spectator ion.
The materials you will need for this lab are 1 6-inch piece of copper wire, 15 milliliters of a 0.1 molar silver nitrate, 1 250 milliliter beaker, 1 600 milliliter beaker, 1 digital scale, 1 glass test tube, parafilm, 1 pipette, 1 glass stirring rod, labeling tape, 1 DH2O water wash bottle, acetone, a test tube rack, 1 per period, and a drying oven. Acquire a 6-inch piece of copper wire and a clean dry test tube. Use the labeling tape and put your period number and table number on the test tube and the 250 milliliter beaker. Next, find the mass of both the copper wire and the labeled 250 milliliter beaker separately. You should round your measurements to the nearest 0.01 gram. Wrap the copper wire around a pen or pencil to create a coil shape. Then stretch the coil slightly and make sure it fits in the test tube. Pour the 15 milliliters of the 0.1 mole silver nitrate into the test tube. Remember to be careful because silver nitrate will stain your skin and clothes. Observe the reaction for 30 minutes and record the observations. Use the parafilm to cover the test tube and allow the reaction to continue for 24 hours.
Bo do bleeb, bo bo geep, bo dwa da do da dwa ma.
Acquire 1 600 milliliter beaker. This will act as the waste container. Using the glass stirring rod, shake the silver crystals from the copper wire and remove the wire from the test tube. Use the wash bottle and rinse the wire into the 250 milliliter beaker. Dip the copper wire into the acetone and leave it to dry. When it dries, find the mass of the wire to the nearest 0.01 gram. After this, set it aside as your instructor has instructed. Carefully transfer the solution from the silver crystals into the 600 milliliter beaker. Rinse the silver crystals with the distilled water while stirring gently with the rod. Let the silver settle and then carefully pour the liquid into the waste beaker. Make sure to remove as much liquid as possible without removing the silver crystals. Dispose of the liquid from the waste beaker into the designated disposal bucket. Do not dump the waste down the drain. Your final silver crystals should be in your 250 milliliter beaker. After the last rinse, give your 250 milliliter beaker to Miss Lynn to place in the drying oven. Then, clean and dry your waste beaker. When the silver is finally dry, find the mass of the silver crystals to the nearest 0.01 gram.
The data for the investigation was split into 2 parts. The first was the raw mass data and the second was the analysis. In the raw mass data table, the mass of copper wire before reaction was found to be 1.17 grams. The mass of the empty labeled 250 milliliter beaker was found to be 35.67 grams. The mass of the copper wire after reaction was found to be 1.13 grams. The mass of beaker with dry silver crystals was found to be 35.80 grams. And lastly, the mass of silver crystals was found to be 0.13 grams. In the analysis table, the mass of the copper wire reacted or lost was 0.04 grams. The moles of copper reacted was 6.29 times 10 to the power of negative 4. The mass of silver formed as stated above was 0.13 grams. The moles of silver formed was 1.2 multiplied by 10 to the power of negative 3. The expected ratio of moles of silver formed to moles of copper reacted was 1.7 to 1. The experimental ratio of moles of silver formed to moles of copper reacted was 1.9 to 1. The atom of silver formed was 7.23 times 10 to the power of 20 atoms. The atoms of copper reacted was 3.79 times 10 to the power of 20 atoms. The experimental ratio of atoms of silver formed to atoms of copper reacted was 1.91 to 1.
The percent yield of silver was 95.7%. The percent error of silver was 4.3%.
In this investigation, a solution of silver nitrate reacted with a copper wire, and both a physical and chemical reaction occurred when doing so. By placing the copper into the solution, pure silver metal and copper nitrate was produced in a single replacement reaction. During this production of silver, the solution changed color quickly, forming a metallic gray. In addition, the copper grew fuzz on the exterior and its size increased. On day 2, silver crystals had formed with the copper wire. From the data collected in this procedure, it can be concluded that the copper wire lost 0.04 grams in order for 0.13 grams of silver crystals to be produced.
When calculated, there was 0.0006 moles of copper reacted and 0.0012 moles of silver produced. Using the number of moles, both the percent yield and the expected yield could be calculated. Such information helps determine mole relationships between the reactants and the product. In this case, the copper metal and silver nitrate reacting to produce silver metal and copper nitrate.